Hi, everybody. Thank you for coming out. Just as a quick comment, I've been a long-time fan of the Denver Java user group. I'll talk a little bit about my background in a second, but really excited to be here. And I know you guys have all the rock stars, both in attendance and as presenters. So thanks for having me. Hope you find tonight's presentation enjoyable. Oh yeah, there we go. There we go. All right, so just a little bit about me. Many years ago, I wrote a book called JPA 101. And shortly after doing that, I was on the JPA 2.0 expert group, along with a couple other Java expert groups. And at that point, I was speaking at conferences and stuff. And then I noticed as I was putting these slides together, there's this really long delay between that book and me over here. And I realized what happened is we had kids. And now my kids have all grown up. So now you see me here with my wife, and there's no kids in the picture. So that's what happened. So here I am, fast forward a few years. And this was me a couple years back at a Ironman 70.3 race. And the guy standing next to me is named Dave Scott. And he is the 6-time Ironman world champion. So for me, this is like standing next to Bill Gates. So I had to put that in there. And then this is me the next day at the end of the race. So when I'm not doing this kind of stuff, I spend most of my time doing triathlons. And then just a quick couple comments about my company and tonight's presentation. So for many years, I've been doing a lot of cloud-related work. Folks at Rip City Software have been using AWS since about 2010. So not at the very, very beginning, but as AWS was kind of coming up and becoming more popular, we've been exposed to and using AWS for a long time. But I've also used Azure and GCP. And when I started Rip City Software, I really wanted to focus on AWS. And it's funny because Chris and I have the same name, and he's from AWS. And we didn't plan that. But I wanted to say that tonight is not a sales pitch on Amazon. Everything you're going to hear about is AWS. My company is an AWS partner. But that's in part because I find the technology stack to be way better than everyone else. And I do have clients we're doing GCP work with. And I just did a year-long project in Azure. So it's not that I won't touch any other environments. But if you at some point think, man, that's a lot of AWS, it's really just because I find the environment to be the most productive for me. So hopefully you can look past that. A lot of what I'm going to talk about tonight tends to be pretty AWS specific, but there are a few services that are kind of ubiquitous, and so I'll mention that as we go. So let's jump in. OK, so what are we going to do tonight? For the next somewhere between 75 and 90 minutes, talk about what is serverless computing. Do a little survey of the environment to see what services fall under the category serverless. What does that mean to you as a developer or an architect, and how you might use serverless technologies in your day-to-day app design and development? We'll look at using serverless. So what does it mean to actually build out serverless compute infrastructures? And what are some of the things that you have to look out for? And what are some of the things that it enables you to do? And then at the very end, we'll just wrap up with a couple of comments about things to sort of look out for when you start diving into serverless. OK, so let's talk a little bit about serverless. And so one of the things that I found when I started my company and working with our clients and then working with various vendors, whether it's Amazon or CloudBees, there is this sales process that all of the reps will use to convince your management why you should learn or use something. And I never really knew that before, so most of my career I was either the guy in the corner that wrote code and you just gave him requirements and I just did stuff, or as the years went by, sometimes I did that or I was leading teams. And so in this sort of starting my own company adventure, I was really surprised by how things were marketed and the way things were sold to executives and leaders, including to me as a business owner. So what I was going to do at the very beginning was just give you a little flavor of some of the ways that stuff is presented, so that when you're in your office or at your desk and your manager or executive comes by and says, hey, I just heard Lambdas are the only thing we should be using, go for it. You'll know, oh, this is what they told him. So let's just jump into that. So usually in these kind of discussions, we'll look at sort of this evolution of computing and moving to the cloud, right? And why would you want to move to the cloud in the first place? Which, for those of you that are in the cloud, that sounds like a no-brainer. But I actually have been working with a whole bunch of companies, including companies with thousands of employees and billions in market cap that are still on-prem. So there's a lot of on-prem out there, right? So as they're moving to the cloud, right, why would you do that? And that's because you want to get scale, right? You want to be able to have elasticity and scalability. So elasticity is that ability to launch many services, or servers, if you will, to handle a load. And scalability is that ability to increase the size of your machine. So starting off at 2 virtual CPUs and maybe jumping up to 32 of them, right? So that's the scalability side. And so the cloud is really good for that. And that was one of the big selling features of moving to the cloud. Of course, there's an amount of reduced maintenance because you're not racking and stacking and you don't have to worry about facilities. And of course, you have a better availability, especially when you look at things like availability zones where you can run your services across many data centers, and if one of them goes down, you're all good. However, when you're in a cloud environment, you still really have to maintain and manage your servers, at least. Well, we'll look at sort of this definition of what do the vendors take care of and what are you responsible for. But you still have to manage capacity, right? So you have to make that decision that I want a certain number of CPUs in my instance, and I want to run X number of instances. So there's still some capacity planning that you have to go through. And you still have to be ready for fault tolerance. So when you think back to any of the big outages, including if you go back to one of the first ones where Netflix lost a bunch of availability around the country, part of that came back to not using all the availability zones. So even today, if you were to build a cloud architecture without what we're going to talk about, you have to think about things like availability zones. And of course, what do you do if maybe you run an ad on the Super Bowl, and normally you have 5 servers running, and because of the Super Bowl traffic, you now need to run 100, right? That's a lot of work to coordinate and stand all those up and manage it and then bring them all down. And so you may have those kind of spiky workloads, right? So all of those things are still something that you have to deal with if we're talking about regular compute instances in a cloud environment. And so here is sort of this picture of the evolution of how things have changed over the years from on-prem with virtual machines and then moving those to the cloud. That would be the early EC2 compute instances in Amazon and all the other vendors. And then, of course, we come out with Docker, which was great because it creates an isolated address space, services. Many of them can run on one machine. Of course, that creates another problem with port management, but that's okay. Gives us a new way of managing compute infrastructure. And then right after that, I actually went and looked up when did Docker first get announced and when did Lambdas get announced, and they're a few months apart, but Docker did come out first, and then the serverless stuff came out second. So that's kind of this transition, right? And so as we make this transition, part of this discussion about why you want to go serverless is going to go through this, which you already talked about, right? Which is, what are you responsible for when you're on-prem? Well, everything, of course. But when we say everything, there's a bunch of things that if you were to talk to your average ops person, they might not think about or talk about power, air conditioning, facilities, security. Like, those aren't everything that ops thinks about. They might think about changing out servers or making sure who has access to the actual room. But these are all the things you have to kind of consider. So when we move to the cloud, we get a few of those things taken care of for us. The facilities, the security. When you think about the level of certification that Amazon or Google or Microsoft have to go through, they have certifications for every country and most standards around the world. Your data center probably hasn't gone through that process, if nothing else because it probably costs too much money and takes too much time. But you get that great reliability and that kind of security in a cloud environment. But when you move to a serverless environment, what the sales pitch is, everything from everything below your code is taken care of. You don't have to worry about high availability, meaning spread across availability zones. You don't have to worry about capacity, although there's a little bit you do with that, but not a lot. The idea is, as a developer, as an organization, you work on your code, the part that delights the customer, not the infrastructure that everybody has to do. There's a phrase that's used for that called undifferentiated heavy lifting or undifferentiated work. Every company has to build a CI pipeline. Every company needs a load balancer. Every company needs to have infrastructure. So why spend your time and resources on those commodity items? Let the cloud providers give those to you, or you're paying for them, but let them take care of them, and you focus on the part that you bring value to, which is the source code. Okay, so that's kind of the get you to the serverless space. But let's talk a little bit about what is serverless. And the very first one I have up here is Lambdas, because that's sort of the first thing people think of. Another name for that is Cloud Functions, I think in the Google space. And the idea there is that you can write a program, and we'll talk about the characteristics of that in a few minutes. But you write a program that has a short amount of time that it runs, and it's basically always available. But then as we go down the list here, the next kind of compute infrastructure is Fargate. So Fargate actually is one of those services that comes in a couple of flavors. One flavor is you decide what EC2 instances you want to run and what their capacity and sizes are, and you're still kind of managing that, but you have this container environment where you can throw as many Docker containers as you want, and Amazon will take care of port mappings and making everything work. But there's also a serverless version. We're still using EC2 instances behind the scenes, but you don't really worry about that. You just say, I'll let you manage the number of instances and the scale, and I don't have to worry about that underlying architecture. So this is an example of, I don't know if there's a real word for it, maybe Chris can tell me, but I'd call it like a hybrid service that gives you a couple of options. But then as we move down the list, you could really throw things like S3, which has been there from day one as part of Amazon, as a serverless compute or a storage option, because you're not defining really any characteristics. There's a few limits about maximum size of a file, and then you have some classifications of S3, like how available, how fast is it fetched, is it long-term storage, but that's not a lot of choices, and those choices mean it's pretty much always available for you. Another one is, that would fall under this is EFS, which is the Elastic File System. It's like a network-attached storage. So that's another service that you just enable, and it scales with your usage. The next column is kind of, in my mind, really interesting. My JPA background, I guess, pointing out here, is this idea of these different databases. So DynamoDB is a NoSQL database. You don't really do, I mean, there's a little bit of configuration you do with DynamoDB, but the idea is it is a very fast, highly available NoSQL storage that becomes a key component in almost all serverless architectures that I've seen. And we'll look at a couple in a few minutes, but pretty much DynamoDB is sort of the de facto backend database that people are going to use because it's fast, because you aren't creating a schema, because you don't have to migrate your schemas or anything. Becomes a great choice. A new entry, I'm thinking maybe the end of last year, beginning of this year, is Aurora. So Aurora is Amazon, I think of it as Amazon's Oracle killer. So when Amazon wanted to get off of Oracle, they spruced up Aurora, and Aurora became the database that allowed them to replace Oracle. And so Aurora comes in a couple of flavors, a MySQL and a Postgres. But here what we're talking about is Aurora Serverless, and that's the idea of using MySQL in a completely serverless environment. And we'll actually look at the configuration for that in a few minutes. But that does open up a new possibility where you can have a relational database, and you only pay for it when it's running. And so there's some interesting side effects from that I'll talk about a little later as well. But it's a great option. The next one here is an API gateway, and that is Amazon's own API gateway. You may have heard of things like Apigee or Kong. They're also API gateways. But the Amazon API gateway also is a managed serverless service. And the reason that matters is because you can count on it scaling to your needs, because you actually don't make any adjustments to how much volume you're going to get. Now, you pay for the requests, and there's account limits and things. But generally speaking, you can just point the gateway in front of other services, and it will scale as needed. And then just to move through these real quick for a couple minutes here, there's some notification type systems like SNS and SQS. Step functions is also an interesting one. This allows you to coordinate workflow. So if you have a step one, let's say I purchase an item on a website, and then when the item gets to the warehouse and someone in the warehouse goes out and picks that item off the shelf, you can have step functions work with mobile apps where that person in the warehouse scans a barcode that triggers a step function, which in turn emails a customer to say, hey, your package is on its way. And you can do that sort of coordination. And then on the analytics side, actually, oh, I missed it right here. AppSync. AppSync's actually a really, really interesting service. I don't know how long it's been there, but it's a GraphQL API. And if you've ever looked at Chris Richardson's microservices design patterns, he has a proxy design pattern where you have a service that sits in front of other services and it coordinates work. Well, the AppSync kind of does that, where you can define an API and it will coordinate calling other services and collecting the results and then returning them to the caller, to the client. So it's actually pretty cool. And then we have some stream stuff over here with Kinesis and Athena. Athena is actually pretty cool. It allows you to create sort of a schema on top of data in an S3 bucket, and then you can query it like a regular SQL database, which is kind of cool. So another term that you may have heard of is this notion of a managed service. So an example of a managed service would be the Relational Data Service, or RDS. And since a managed service is kind of infrastructure provided by a cloud provider, and a serverless environment is infrastructure provided by a cloud provider, how are they different, right? What's the difference and why do you care? So the best way to do that is to just jump into an example. So here we have, I have to look at it because I can't read it over here. So here we have Elastic MapReduce. And Elastic MapReduce is Amazon's managed big data type service. And you can see here that there are a collection of services with the right versions that all work together predefined for you. So there's an example, right? As an architect or as a developer, you just have to look at this list and go, okay, I can kind of work with that collection of services. So you pick that. And then down here, though, you're still picking the kind of compute infrastructure that you want. And of course, the bigger the infrastructure, the faster it's going to process, but of course, the more money it's going to cost you. And so this is an example of a managed service where here you get to make a couple of choices, right? What's the configuration and what's the compute instance size? And again, we're going to come back to this in a second, but this actually opens up a discussion for another item, which is called the shared responsibility model. And much like the on-prem versus cloud, those diagrams I showed you, the shared responsibility model is also sort of an underlying concept that as developers, I don't know if we always know about. I know it was new to me when I read this. And it's the idea here, this bottom portion is referred to as security of the cloud. And so this is what a cloud provider, specifically here AWS, what they say they're going to take care of. So they're going to take care of everything below the host operating system. So they're going to take care of their infrastructure. They're going to make sure if disks fail that they replace them, that they take care of racking and stacking. But your responsibility in managed services, at least, or compute instances, is going to be everything up here. So what's my OS patch level? When a bug like Heartbleed comes out, it's still your responsibility to patch your operating systems because that's your responsibility up here. How's my data encrypted? What network is my data in? Is it on the internet or not, right? Those are all your choices. And so I was a little surprised when I first saw this because I kind of thought that perhaps the cloud providers' responsibilities kind of dipped up occasionally a little bit higher here. So seeing this was interesting. But when we move to serverless, which is nice, is this responsibility moves up a little bit. You notice here it says platform management and, encryption, network traffic, code encryption, excuse me. Those things are all decided for you. So you don't have to worry about, is the OS patched? Is my infrastructure working correctly? Now, I still have to make a decision, right, if I'm going to encrypt user data, because maybe data doesn't need to be encrypted. So that's still my responsibility. But that kind of makes sense. You might think, well, that's sort of what I would have thought I'd be responsible for. So when you move to a serverless model, there is this change of responsibility, meaning you have less to worry about. The cloud provider will take care of more of the problem for you. So let's compare that to a managed relational data service and a serverless data service. Whoops, excuse me. There we go. So here we have two Aurora DB instances. On the left, we have an RDS, a managed RDS, and on the right, we have serverless. And so you can see here, right out of the gate, we have less options on the right-hand side. So remember when we said that there's the platform management? Well, EMR gave you a whole list of choices. Well, here all of a sudden I don't really have too many choices, right? I get to use MySQL. I think Postgres is coming. Postgres isn't out yet, is it? Do you know? On serverless? Okay. Yeah, I don't think it was last time I checked, but nonetheless, here you can see we're going to pick MySQL. But over here, I had to pick, my my version of the database. I had to pick whether or not I wanted, how many CPUs. And then, of course, I had to manage or high availability, right? Multi-zone deployment. And so, so there's less choices, and therefore more available. But over here, most of the newer serverless options. So remember, I said S3 doesn't give you a lot of choices. Here you have what's called a Aurora capacity unit. And so this is defining how much memory you want available. And the idea is the bigger these numbers, the more memory is made available to your serverless database. And the idea there would be a faster start time, be able to process data quicker and things. And so there's going to be something that you're going to have to configure. And then down here, we're saying how long do I want my service to be idle before I shut it down. And so the default here is 5 minutes. I think that's the lowest you can go. But that just gives you an idea of the flavor of, back here, we had all these choices. And here, we just replaced them with a couple of choices around memory size. So what do you get if you go to a serverless environment? Ease of management, right? Because you're not dealing with all that underlying infrastructure. High availability is kind of built in. That means spreading across those availability zones, those data centers. And of course, all of the serverless options will grow to meet whatever the demand is. There's some things you can do to tweak that a little bit, but generally speaking, the idea is they will expand to meet the capacity. So that sounds really good, right? There's lots of stuff it's taken care of. There's got to be some gotchas. So if we look at, this is even true on RDS, I believe, but like on the serverless side, you don't really get to choose the port number. You don't get to choose which version of the database. For MySQL, it was 5.6. And in the case of Aurora Serverless, it's only in the VPC and it's on a private subnet. So Amazon has made some decisions to sort of move and isolate that data for you so that you intentionally have to do something to get the data out to the public. And it's not changing the subnet because you can't do that, or at least you couldn't earlier this year. You actually have to put something in either a public-facing subnet or have an API gateway call a service that talks to that data. So the idea here is the cloud providers are trying to protect you a little bit from making choices that might expose your data because you unintentionally did that. And you hear that about S3 buckets being exposed. And by the way, on that front, Amazon's really locked down the S3 buckets now. It's pretty hard to just accidentally put your bucket on the internet. As a matter of fact, it's sometimes hard to just make it available in general, which is not a bad thing. So those are some of the gotchas. So when this is marketed to your leadership or your execs or maybe even to you, right, they're going to be told that there's nothing to provision. And we saw there is a little bit that you have to manage, right? So it's not completely nothing to do. And that it will scale with usage, which is true. That you never have to pay for idle, which is true, but you also have to, on some services, set those timeout periods. And of course, availability and fault tolerance are built in, which is true. Okay, so let's jump into using Lambdas. And I thought Lambdas would be a good area to focus in on because that tends to be what most people think of when they think of serverless. But we will look at a few other services in a few slides. So when it comes to Lambdas, here are the primary languages that you get to choose from. We see Java here. I had to put that at the top. And we have all these other languages. But there's an interesting thing that they say on the Lambdas that you can really sort of run any language you want. It's not built in out of the box, but they give you the APIs and the tools to do that. And Kelsey Hightower from Google was speaking at KubeCon last year. And he was, he's from Google. But he was singing the praises of Lambda, saying that Amazon did a great job on this, which I thought was good of him. And he said that there's a lot the Kubernetes and Google environment could really learn from what Lambdas are doing. And what he did is he thought, there's this feature in Lambdas called layers, which is a lot like a Docker container with its layers. And so what he decided to do was write a program in Fortran in a Docker container, extract the layers from the Docker container, load them into a Lambda, and then he ran Fortran in a Lambda. And so you can pretty much run whatever you'd like. It might take a little more work, but if you want to just point and click, any of these languages will work right away. So there's some things you need to be aware of. There's this idea of a short execution time. So a Lambda function has a 15-minute execution window. Warm-up is not considered part of that time, but if you go over 15 minutes, you just get shut off. You probably want something that's more like an intermittent execution. So you don't want something that's going to run all day, every day, because that's sort of not the purpose of a Lambda. You want something that's going to run for a short period of time and then stop. Now, it may get called all day long. That's OK. But it's meant to be short-running little bits of code. When you move your code to a Lambda, there's really only one entry point. So it's kind of like a main method in a Java class. There's ways to get around this, but all Lambdas have one method that gets called, and from there you can do other things. And of course, you can still access all of the other resources within AWS. So you can hit a relational database. You can hit a NoSQL database. You can use DynamoDB. And the deployment's a little different. You don't take a Docker container or a WAR file and install that on a machine. What you're really going to do is take a zip file and upload it to an S3 bucket. And then from there, you message the Lambda and say, here's my application. And then the Lambda takes over from there. So the deployment's a little bit different. Once you're making that happen, once you're bringing that code into the Lambda, you have a bunch of different options for the deployment. The new phrase for that is traffic shifting. Maybe it's not new. It's new to me this year. Is the idea of a canary deploy where you have a little bit of traffic going to your application and then the rest of it's going over here. Well, you could rephrase that. It's traffic shifting. We're shifting some traffic here and the rest goes over there. And Lambdas give you a lot of choices on how you might want to do that traffic shifting from a canary type release to a more blue-green where you're just kind of swapping versions and stuff. But that's, I think of all the cloud providers, in my mind, Amazon does, whether it's blue-green, canary, any kind of traffic shifting, the best. And when I went to Kubernetes, doing a lot of work in Kubernetes, I was just surprised at how much I had to do by hand and how I can kind of just tell some of the AWS infrastructure, just do a blue-green deployment, and it just kind of takes care of it for you. So, OK, so let's jump in. So we kind of talked a little bit about this here. One of the, so the file is up. Well, yeah, sorry, I got off track here. This is how you might use a Lambda. So a Lambda is kind of event-based, maybe. And I say maybe because the idea is something happens and it triggers the Lambda, right? So uploading a file to an S3 bucket is a common way for a Lambda to be invoked. An SQS message comes in and that causes the Lambda to do something. Maybe the API gateway or a time-scheduled event. And there's a lot of different ways that you can have your Lambda get triggered. So we already talked about this a little bit about startup time. There's a little bit of this warm-up period where not only is the Lambda brought into memory, but it's actually being initialized. And we'll talk about that a little bit later. But it turns out there's a 10-second window where your Lambda is given a lot more compute resources to get up and running. And now you may not need all 10 seconds, but if you do, it's there for you. And then the idea of a cold start means the Lambda ran, and maybe nothing's happened for 10, 15 minutes, and so the Lambda got swapped out. And now a request comes in. You got to go through that whole initialization process again. And sometimes that warming up period can be a bit of a deal breaker. And so there's a discussion in the serverless community of, do I deploy monolithic Lambdas or single-purpose Lambdas? And the idea there is if I have, say, 5 different things I want my Lambda to do, and 2 of them are really hot. They happen all the time, all day long. And 3 of them happen a couple times a day, but they're very compute intensive for a few minutes. You can put all 5 of them in a Lambda, deploy it, and those 2 that are really busy, they just keep all the code in memory. And when your slower Lambdas or your infrequent Lambdas are called, they're like instantly there to go. And so there's just some different things to think about. I think when you start worrying about warm and cold start times, you probably have a bigger problem, which is a good problem. You're probably getting more traffic than you were expecting, and so that's not a bad thing to have to deal with, but something to think about. And this one here, don't assume you have state across executions. We'll see how this comes into play in a little bit. But I wrote a Python app that I thought wasn't taking care of or wasn't thinking about shared state. or cache state, but it actually was. And so it worked great for the first 10 minutes. And the next time it ran, it failed. And I didn't realize I had a little bit of memory that was just sticking around between invocations. So sometimes that kind of stuff can bite you the first time. So just as a quick, when might you use, let me go back one more time. When might you use a serverless system, right? You might want to build a web application or do some event processing, maybe build a chatbot or something, things that sort of have these short little implementation times. So here's a really interesting one, is hosting a static website. So you build out your HTML and JavaScript, and you might just deploy that to an S3 bucket. And there's a great setup in S3 that actually lets you fully configure a website with CloudFront doing your CDN in front of that, Route 53 doing your DNS resolution. And you can have the whole site in S3, and you really just pay for the number of requests that come through, and there's no infrastructure to manage. But now, with serverless, we can actually create an entirely serverless deployment. And so the idea might be that we create a SPA, a single-page app that's put into S3, and that gets served up to customers. When your SPA application wants to interact with a database or the back end, it goes through an API gateway, and that API gateway then invokes a Lambda. And then that Lambda calls DynamoDB. And finally, we have an end-to-end 100% serverless solution that will scale based on the growth of your system.
So what's DynamoDB have in its web pages?
Oh, so the DynamoDB is your database. So if you were, let's say you were storing information about customers or page hits or whatever data you want to store, DynamoDB becomes that database. And since it's a serverless database, it works well with this sort of instant on, instant off kind of Lambda. Whereas a relational database, remember, had that timing window where it's only going to run, it has to warm up. It might take a little bit longer, and then it'll shut down after infrequent use. And so DynamoDB just becomes a nice database to fit with this. And we'll see a little architecture diagram in a minute that talks about this, because this stack here is pretty popular within the serverless world. And so here is just talking about some of the different kinds of events that might trigger your Lambda. And this is actually an old picture, because this has been replaced because there's so many different things that will trigger a Lambda. But you can just see a little flavor of some of the things that you can do. And there's all these different kinds of reasons you might build a Lambda. One of our clients uses Lambdas to power all of their chat. They're doing some Alexa work, and so they build some skills that are handled in Lambda. And so there's a lot of different things you can do. So this one here is kind of interesting, a policy engine. You could set up certain requirements for how security groups work, and you can even use a Lambda to see that someone changed permissions in a security group, and the Lambda puts those permissions back. So you can do a lot of stuff with that. OK, so let's jump into some practical. I have some demos, I promise. They're coming up. And so let's actually create a Lambda by hand. We'll do everything by hand. We'll do it with point and click in the UI. I'll kind of talk about it as we go. And the idea here is just to get a feel for what's all involved with creating a simple Lambda function. And part of this, I wanted to expose people that were new to serverless to the kind of common environments you're going to run into. So Python and Node tend to be very, very popular in this space. VS Code, Visual Studio Code for Microsoft, is a very popular editor that everybody uses. So you're going to see a bunch of that here. And I thought it would be good to do that, because if you find yourself researching these things, you're not going to be super surprised when you see them. Plus, there might be a point or two here that will help us Java people who are used to Gradle or Maven understand what pip env is and why are you using npm everywhere. I know when I first started doing this, I was annoyed that Node was everywhere, but I've gotten over myself. It's not so bad. So let's build our first Lambda. Now, let's see, where did my mouse go? OK. All right, so we are just going to start. And so because I want to make sure you know that this is all from scratch, I'll start making the directory and going from there, so there's no frameworks pre-built or preloaded, just a super basic Lambda. So we immediately jump into VS Code. and we're going to use Python. And so there's a great dependency management tool called pipenv. And right here, this is a lot. Oh, here, I'll wait till this goes past here when it gets to color. There you go. This is a lot like a Maven file, like a POM XML or a Gradle build file. We're just listing off all of the tools we want. There's something about this that's really cool, though, that is not available in the Java space. And over here under dev packages, right, these are like provided dependencies in Maven, right? They're not things that you're going to have in the production environment, or these are like test dependencies in Maven. But what's really cool is you can put things in here like AWS, and that'll download the AWS CLI into your project. So you don't actually have to have it pre-installed, which is kind of nice and can be kind of powerful. And it's a virtual environment, meaning you have to enter into the environment, which we'll see in a second, and then you have all these tools available to you. And when you exit that environment, all those tools are gone. And which is really nice because then you don't have to have your machine cluttered with a million tools you don't use. So, okay. So now that we've created our file, we're going to start the pipenv process. And so here I say pipenv install. You may recognize this from NPM when you might do NPM install if you've seen people do node work. So the funny thing about this, you know how Maven, the first time you run it, it's really annoying, and then eventually it's quicker. Every time you say pipenv install, it's going to run through that process, even if you're not on the internet. I don't know why it's so slow. But anyway, that's the way it works. So now I will, this is entering the environment. So I said pipenv shell. And so this here is loading up all that virtual environment that I had. So if I had put AWS there, now my AWS CLI would be available. I happen to have it installed already, so that's why I didn't do it there. OK, so what we've done now is we've created our environment. We're going to jump back into VS Code, and we're going to create a really simple Lambda. So that's it. That's the whole Lambda. It's going to say hello world, but I'll wait till it finishes here to show you a couple things. OK, so here is your entry point. So every Lambda has an entry point, and it's typically going to take an event in a context. The event is what triggered your Lambda, and then context is a bunch of information about your execution environment. And then from here, you implement your code. And so here, all we're going to do is say hello world. And so that's about it for the Lambda. So now we have to go and package the Lambda. And so the way that works is all of your dependencies need to be packaged into a single zip file. So here what we're doing is we're using pipenv to get all the dependencies together in a file, requirements.txt. And then we're going to install everything from that file into this build directory. And that's basically installing, if you will, all my dependencies. So that's what that is. Next, I'll copy over my Lambda. So we'll just do a quick copy of the Python file. And now I can zip it up. Here's the funny thing. It doesn't look like there was that much stuff, right? Watch what happens when I run the zip. There's a whole bunch of stuff, like way more than I thought showed on the screen. Seems like a lot more, right? Anyways, that gets all packaged up, creates a zip file, and then gets pushed into an S3 bucket. And so once that goes into the S3 bucket, we are ready to connect it to a Lambda. So here we go, pushing that up. Fortunately, I don't have too slow of a connection, so that didn't take too long. OK, so now we're going to pop over to AWS, to the console. And in the console, we're going to go to the Lambda screen and manually create it by hand. I wouldn't recommend doing this too often after the first time. Terraform is a great tool to do this, or even just the AWS CLI. But here you can see blueprints. When you're first trying to get your head around how this works, there's a ton of stuff in blueprints, like image resizing and file processing and stuff. And so that would not only give you a setup, it gives you the code that you can start with. And sometimes some of the blueprints are good enough as is, you can just use them. But this here we're just going to do from scratch. So we're going to give our Lambda a name. And then here, next, we will pick just showing you the blueprints. All right, so here is where you can see all the different languages that kind of come out of the box available. So we're going to pick Python. And then the last part here is the roles. And if anyone's used AWS, you probably are aware that roles can be the bane of your existence in the sense that they're super powerful, and they can actually help you eliminate using passwords and create a secure environment, which is really good. But if you don't quite understand that, your first couple of encounters with roles and lambdas can be a little confusing. So for example, when I was doing this demo, I copied a lambda and just used the exact same security group. And what happened is the new lambda, which had a new name, wrote to a completely different CloudWatch file, a CloudWatch log. And that CloudWatch log was not in my security group, which meant the lambda could write data, but it never went anywhere, and I could never find the log. So I had to go in and change my security group. So little things like that that until you're familiar with using it can sometimes trip you up. So here we'll just pick a role. So I have a couple of existing roles. And then next we're going to, OK, so now it's been uploaded. You can see here's our function. And right here you can see those are those layers I was talking about. So that's the section that Kelsey Hightower went in and adjusted to give himself Fortran capabilities. And by default, they give you a little sample bit of code here that we're going to replace. And by the way, that IDE, Cloud9, which is Amazon's IDE in the browser, and the one you just saw, actually are really, really good. They're not as powerful as your desktop, but they're actually pretty powerful. So here we're just copying the URL to that S3 bucket. We're going to paste that in, and we're almost done. And so now we have to enter what's the entry point for this Lambda. And so for Node in Python, it's filename.function. And so I happen to call mine hello, and my function is world, so my entry point is hello.world. This kind of tripped me up at first because I wasn't sure exactly how to connect everything, and I didn't know what to do because I changed my entry point, and then it didn't work. And so the last thing we're going to do is do a quick test. And here what is happening is there's a lot of information that can come into your event, that first part that triggered your Lambda. And so here the Lambda tool is creating a sample event for us. And so then I can hit test, and we come down here, see it's successful, and there's hello world. A couple other things you can see. We ran for 12 milliseconds. We were billed for 100, because Lambdas bill in 100 millisecond increments. And here you can see that it took 300 milliseconds to initialize our Lambda. And so there's just a little information here that can be helpful. And that is all we have for that. OK. OK, so is there a better way to do this? There probably is, right? There's probably a way we can be a little bit faster, do a little bit more, be a little more productive, have maybe some better testing. So let's take a quick look at that. And let's look at some frameworks. So here are a list, not in any particular order. I don't know if these are necessarily the most popular frameworks in the serverless space. But there's a couple of really good ones here. We're not going to look at Stackery. But Stackery actually has got a pretty good solution built on VS Code with a visual editor. So you can drag different components around, connect them visually. And then from there, you can actually run your Lambda in VS Code in the IDE. You can debug the Lambda as it's running in the Lambda. A lot of really good features. But it's a little more than we have time to get into today. So we're going to take a look at all these other guys. So in order to do this, there's three things you need. Now, my Python example, we could get away with that in our virtual environment, right? But if you're not going to do that, we need to install the AWS CLI, NPM, and Node.js. So I know as Java developers, that might be like, oh no, but that's OK. And so then here we just, real quick install process, curl, then you run the install script, and then Amazon AWS CLI is ready. OK, so let's, oh, of course, I hit the wrong button, sorry. One more. All right, so let's take a look at the first framework called Architect. One of the reason I put this page up here is I feel like the serverless space, because it's new, it has a lot of lofty goals and ambitions, and people speak of freedom and the ability to build whatever you want. So it kind of sounds like Web 1.0 back in the day, and it's kind of mentioned in here about this great new compute environment. So let's take a look at how it works. So the Arc framework, or Architect framework, excuse me, is based on this .arc file, and you use that file to define, the app. So add app, and we're going to go through this in a second. But this set of steps here on the left is all that you need to do to install and run and interact with Architect. So here, we're going to just do that whole thing. So we start off with npm install. This is going to be a common theme. We get that installed. We now create this ARC file. And so here I put an app in. And so that's going to be my Lambda test app. And then at HTTP is defining an API gateway. So what this is going to do is create a gateway and create a Lambda. And so you can see here I run the create command. And here is all the output that comes from the create command. And after that's done, here I'm using HTTPy, my favorite tool for hitting endpoints. And you can see all the output that came back out of 200. And eventually down at the bottom, we got a hello world. And so I didn't have to write a whole lot of code. I just made some declarations. And Architect went and built a whole bunch of stuff for me. On the file system, there's a bunch of files there that you can then go in and edit. And it works. That website's available publicly. OK, let's look at serverless. I think, if anything, serverless wins for the best framework name, right? Serverless is pretty cool. It's also built all on Node. And you can see on their homepage, they give you 3 lines to get serverless up and running. So here is my little encounter with serverless. So starting off, I installed it. Actually, I can't tell what the heck the next one. Oh, yeah. So they have templates. And so I pulled out the Hello World template. So that kind of tells us they have a lot of different solutions you could pick from, pre-built code. So it's going to do all of its boilerplate code. And now, so that's what's starting here. And then down here, we're going to say deploy, which is going to push this Lambda to AWS. And so you can see that's what all this was deploying here. And then finally, I run HTTPy again and hit the endpoint. You can see it has a little bit of different output, and it's maybe more oriented to a JSON payload, because you see JSON is output at the bottom. But that's kind of my hello world. OK, next framework is Amplify. And this is Amazon's own framework that they provide to help you build serverless functions. It actually does a lot. Not only will it create serverless functions, it can create Cognito user pools, which is kind of like Okta, but not exactly. Gives you a way to do single sign-on and create users and login and registration and stuff for your application. And all the other services, just about everything Amazon offers, I think Amplify can kind of interact with. So here's a quick startup. Like before, we start off with npm again, and we use npm to install our services and gets you up and running. My little notes here, I kind of found Amplify's learning curve a little too steep. I actually haven't gone back, having gone through all these other frameworks and been doing this for the last year. I might not find it so difficult, but for me, for sure, this was way too complicated when I started. But I have some friends who swear by Amplify as the go-to tool for everything they do. So your mileage may vary, but that's just my 2 cents on Amplify. OK, next is Up. Up is probably my favorite framework because of its simplicity. I love how it's got this minimalist or almost brutalist architecture style here. And so Up is pretty straightforward. You run Up, the command, and you notice right here I get an error, and that's because there's no Git repo. So we'll go and create a Git repo, and then we run Up again. Then I go and create a file. So Up isn't going to do a bunch of code gen like the other framework, so I had to go create a little Node web service and then a description of that service for Up. And then I just run Up. And this actually creates and deploys the service. I was actually a little surprised. I'm like, geez, they should have asked me if they want to do that. They just shoved it all into AWS. But then they give you this nice little API endpoint Up URL, which will tell you what's the path that you just created. You can see the URL. It's right there. But if you didn't want to type that in, you can just say Up URL. For those that have used Terraform, this kind of reminds me of Terraform's output variables, where you can run TF output or Terraform output, and Terraform will tell you about everything it knows. That's kind of what's happening here, right? Up knows what it did, so it's saying, here's the URL. And you can see the output that came out from Up. OK. So the question really is, do you need a framework for all this stuff? And more importantly, will your environment allow a framework? When I first started doing this, I thought, well, I use frameworks for everything. So I'm going to use a framework for Lambdas. I'm going to use a framework for serverless. But it turns out that these frameworks need really, really permissive permissions. So the user or role that they're given needs to be able to create resources in AWS and deploy resources. And a well-run, mature cloud environment for your organization probably won't let an application do that. They're going to want to have their own approach to making sure whether it's a regulatory issue or what have you is all handled correctly. So you may find that running a serverless framework is great to get started, but that may not be what you get to use at the office, if you will. So I thought maybe what we should do is not do it totally from scratch, but let's just build an entire serverless application from scratch. This is what it's going to look like. And so this is kind of a very common design pattern where you, so Lambdas, are not publicly accessible. They're not in a VPC. They're not on the internet. So you need somehow to get to your Lambda. Here we're seeing API Gateway as a common way. Now you could also on a EC2 instance run Kong. You could run another API service, but you're going to need to run something that's on the internet or publicly accessible that will talk to the Lambda. And then here we're running a DynamoDB database. Again, this just kind of fits that serverless model where there's a bunch of services that work well together. Amazon's done a lot of work to make them move fluently together. And so this becomes a great database. And I like NoSQL databases. I used to be a diehard relational person. And then the speed and ease of NoSQL just kind of won me over. I hate migrating schemas, right, with relational databases. So this is really good. There's a common approach that you could do here that I didn't show you, which is instead of an API gateway, you could put an application load balancer. And an application load balancer can be a TLS, or transport layer security termination point. It can be on the internet, and it can resolve to a domain name. So foo.mysystem.com could then hit the ALB. The ALB can then call the Lambda. So you have a few choices. There's a bunch more than those two, but those are kind of the common ones. So let's build an all serverless solution. And when we're doing this, all those serverless components that you need, like DynamoDB, when you allocate those, the phrase people might use for that is creating your cloud-side architecture or your cloud-side resources. But I really like to build stuff on my laptop. So what if we do it all local? And when I say all local, I mean let's use the AWS CLI. Yes, let's use tools that Amazon, that you would use to manage your Amazon environment, but let's do it all local. So no cloud at all. Because as a developer, I want a very, very fast turnaround time, right? I want to make a code change, test it, make sure it works, move on to my next change, eventually creating my merge or pull request, and then it can go to production or your test environment. But I want to be able to move quickly. So the answer to this is LocalStack. LocalStack was created by Atlassian back in 2016. In June of 2017, it moved out of the Atlassian namespace and became its own repo, LocalStack, on GitHub. And it is a really great tool. And let's take a look at why. So if you are building microservices or you're used to building applications where you run tests locally, and then you have a CI environment where you run all of your regression and your integration tests, and then eventually you deploy services to an environment, and maybe you run your tests against that, and then you swap it into production. If you're used to that kind of a workflow, LocalStack actually makes this possible for serverless computing. And so what you're seeing here is we have a service. Maybe it's our Lambda. Now, in this particular case, you'll notice there's a Lambda right here. So this could actually just be a Java microservice, maybe. And the idea is on my laptop, I've got a database, a gateway, and a Lambda. So I got 3 services. And my microservice is talking to them without any changes. And that's all running local. Then we take that same configuration and we put it into our CI pipeline. And here, this is Travis CI, the GitHub CI tool. We're using GitLab right now for this. So we do a very similar thing right now with GitLab. And the idea is, in a very cheap way, I can make sure my APIs are working, make sure all my integration is working, and this is API compatible. And finally, my service gets put into production, and it's all the same services, except these are the real services, and I'm really in production. And so LocalStack makes that possible. So this is sort of the list of services that LocalStack provides. And for example, I mentioned application load balancers. You'll notice there's no ALB on here because it doesn't quite make sense for how this is working. But you'll notice DynamoDB is up there, S3 is up there. Let me see, look over here, I guess. Cloud Functions, STS, IAM, like pretty much everything else. The more common things are available here. Things like QuantumDB, which is one of my favorite projects in AWS. I always like to think of it as a blockchain-style database. It uses ideas similar to a blockchain with a mutable history and allows you to create a ledger database. I guess the real name is Quantum Ledger DB. Great tool for companies that want that immutable history and would like the benefits of blockchain without all the stuff that it brings to the table. Quantum Ledger DB is a great choice. You notice it's not here, but it also was created like at the end of last year. And so if you're building Quantum Ledger DB stuff, maybe you have to live with cloud-side resources. But for the majority of us, this is going to hit all of our needs. The cool thing about LocalStack, as I mentioned, is it uses all of the AWS APIs. I would say, in my mind, the two companies that do the best job of this are Amazon and Apple. Apple, as a former Apple developer, you're really told follow the APIs, and then Apple changes stuff around you all the time, and it just continues to work because you're following the API. So here, LocalStack follows all of the API endpoints that AWS provides, and because of that, they work together. Another cool thing is the AWS CLI includes a parameter called -- endpoint URL. So somewhere in AWS, they knew somebody was going to start pointing the CLI to different places. And so endpoint URL is the tool that we use. And you'll see this in a minute. But it's what enables us to use the API against LocalStack. So here is LocalStack in a Docker Compose file. This is taken right from the LocalStack repo in GitHub. Not a whole lot of exciting stuff here. This is the Docker image. And then down here, we have a bunch of variables that you can set. But I thought this was kind of interesting. There's such a common set of infrastructure for serverless that there's one defined keyword in LocalStack, and that is serverless. And serverless will bring up IAM, that's your identity and access management, a Lambda, a DynamoDB database, an API gateway, an S3 bucket, or S3 as a service, and simple notification service. So those all come, and I think SQS, I missed one on my list here, but those are all sort of the stack, if you will, for a serverless environment. So I have a little video we're going to go through here in a sec, but what I wanted to do was show you how this would play out if you were going to build a Python application. So you saw pip env, that gets us rolling. From there, I'm going to use a framework in Python called Flask. You may have also heard of one called Django. They're both web service type or frameworks for Python. And here, we're creating a real simple API that fetches employees. We have a post to create them and a get to get them. And that's all the code that's really needed to both implement the endpoint and interact with DynamoDB. So as a good Java developer, I created a service-like endpoint class here. And this is where all the DynamoDB calls are made. So at the top here, you can see getting right up here, Bodo3 resource. Cool thing about Bodo3 is this is Amazon's auto-generated Python-based API. So every service in AWS has an API. And whenever those APIs change, the Bodo library runs, collects all of that dynamically, generates documentation and a Python implementation, and publishes it to GitHub. And so that means that if you want the latest and greatest way to interact with AWS, you use Bodo. And we're going to use that to talk to LocalStack. So here we fetch the DynamoDB resource. We get to the table. And here, one of the things I love about Python is this nice fluent interface here, or this really easy readable JSON syntax. And then I stick it in the database. And that's it. OK, so I've got this web service. I can run it on my laptop. I can interact with it like any other web service that I've built. I can use all my tools. I'm very happy. But now I want to create a Lambda. Remember, Lambdas have a single entry point. And this is how you do it. Here, remember we talked about the serverless framework. So the serverless framework offers a wrapper class called Whiskey. That's why there's a whiskey glass in case you forget the name. So serverless Whiskey is the Python way of handling HTTP requests. And so what this is going to do is take all of that information that an API gateway creates, all of that context data, and it's going to take all of that and figure out, based on that, what endpoint you really want to call in the Flask application. And this is all I had to do to map my Flask app to a Lambda. That's it. So from there, what I want to do is I want to do two things. I want to create a database, a Lambda, and I want to create a DynamoDB table. So this is the API call. And you notice here is the endpoint URL. So this is how we hit LocalStack instead of the real AWS. And then it's API compatible. If I took these lines off, I'd be doing it in my account, or whatever account I'm pointing to. So this is how you can see where you create the Lambda, and we upload a file to it. And down here, we're creating a table with its hash key. DynamoDB's a key value store. And so that's right there. And then there's one other thing. If I'm going to run locally, I'm going to just run with my Flask app, right? You can think of it as a Spring Boot app. But at some point, I might want to invoke my Lambda directly. So I don't want to go through an API gateway, but I want to call my Lambda. But we just put Whiskey in front of that, which means I have to call it, passing in all this data that you would get from an API gateway. So there's yet another tool called the SAM, or Serverless Application Model, that Amazon provides that will generate all of that metadata you need to simulate an API call. So remember when I went to test on my raw application and it had 3 keys and values? This is the programmatic way to do the same thing. And what this is going to do is, you notice I put here path employees, and I put some UUID. So that is the endpoint I want to hit. And so SAM will generate all of the data that an API gateway would create. And then down here, I invoke the Lambda. Again, you notice I'm using the CLI endpoint, and I say, here's the function I want you to hit, and I want you to take this output and pass that in. And so I just invoke the Lambda locally on my laptop, and I can see how it works. If it's not working, I can adjust it as needed. OK, so let's do a quick look at all of this running with LocalStack. OK, so here what I did is LocalStack doesn't care, but the AWS CLI will look at your Amazon keys to figure out what to talk to. And so one of the ways to get around typing in all of those keys is to put them in environment variables. So over here, I'm doing this command to set up those API keys, because even though I'm going to use endpoint URL, if I've got real Amazon keys, it gets confused in, I don't know why, but it gets confused in there. So here, I just make sure I set all my AWS keys, my key, my secret, to dummy values. But now here, we are running, and we're going to start up all of our different AWS services in LocalStack. And this will take just a minute. And once this comes to the ready prompt, there we go. At this point, I can now interact with LocalStack on those various ports, and it'll act like the various AWS services. So what we're going to do now is we are going to, did I just, wow, I must have gone, my apologies, I went backwards. Sorry about that. OK. And this is real time, so it shouldn't take much longer than this on your own laptop to bring this stuff up. OK, so what we're going to do is we're going to go back to VS Code. And here you can see my function. So what we're going to do is we're going to do a little regular developer workflow. I'm just going to set some breakpoints. I'm not going to use LocalStack for a minute. I'm just going to actually run my Flask app. So what I'm going to do is make an HTTP PI call. And there we can see the endpoint got hit. Now, the reason I'm showing you this is because one of the problems with a serverless environment is it's a little hard to debug and interact with. And so here I can build an application that's just like a regular app, and just kind of showing that to you by using Flask. Okay. So now what I'm going to do is I'm going to go back into that pip env shell, and I wrote a shell script which will package my code. So I'm doing the same thing you saw earlier. I'm now creating that Lambda. You saw the API call for that. I'm creating the DynamoDB table. You saw the call for that. And the last thing, the thing I didn't show you, is all the calls I have to do to the API gateway to set it up. But we've done that, and down here at the very bottom are the URLs I could use locally to call LocalStack. And so we'll do that. So I'm going to run, so remember I showed you how to generate a function. So I just generated a function, and I went and invoked it, and now here you see all the output that came back from my Lambda. And that's going through the Lambda to show you that it executed. So here is a cool little tool called Commandeer. And Commandeer is a visual Electron-based app that will manage AWS resources for you. Does a great job. But it also has one for LocalStack. And so you can click on LocalStack. It'll look at your local environment and show you all the services that are running. Now, what's cool about this is it's kind of hard to tell sometimes, like, did my data go into a database? It's going into this composed environment. I don't know what's happening. You can dig around, but it's not as readable. So here what I can do is I can actually go to DynamoDB and click on my table and go look at the data, and we see the two values that I just put into the database. And so that works just as is with LocalStack. Oh, I am really sorry. I don't know how that happened. 1 second. Oh. Okay, back up to here. All right, let's try this again. I'm like, hold on, that's not the right presentation. We have a bonus. All the source code you can find here, and I'll get these slides and stuff available to everybody so you can get these later. But what we're going to do is we're going to build a Java Lambda. So we're going to do a similar thing, taking a Spring Boot app and turning it into a Lambda. So there's 3 things we're going to do. We're going to create a handler, just like we did with Whiskey. We are going to adjust a little bit how Spring Boot works to be more efficient in a Lambda environment. And then we're going to build a fat jar. So the first thing here, this is how we wrap or map a Spring Boot application to a Lambda. So this bottom part here looks just like Whiskey, right? There's not a whole lot going on, except you have this handler class. It's the static variable. And so here's an example of where we actually are leveraging the initialization time, and we're initializing the fact that every time the Lambda is loaded, there is some shared state. So remember I said don't worry, don't consider shared state? Well, this is a little bit of a violation of that. And this is actually right from the Amazon docs. So the idea is that 10-second boot time gives your resources a little bit of time to start up. And we all know Spring apps can sometimes take a little bit of time to get rolling. And so by making this a static variable, it'll get called once at the start of the app. It will pull in this product service.class. That's my main class. And what that'll do is cache that initialization and loading for every other request until it gets loaded out of memory. And so there's that little connection. And so product service.class should look pretty familiar to you. This is kind of the class we all typically ignore or may ignore. But one little change that we put here is this at import. And at import isn't new either. What is new is trying to shut down the auto discovery of Spring. And the reason we're doing that is we want Spring to have to do no searching to find what it needs to start up your app, with the idea of bringing down that boot time. And so this is the way you do that. If you had a bunch of other controllers and classes, you just list them here. And there's a few other changes you can do. If you use constructor injection, instead of leaving just the types, you can provide some hints to Spring using named parameters. And Spring will then quickly find what you're looking for and not scan the class path. Because in the Lambda space, we're trying to reduce as many of these sort of developer-friendly features because we don't have a lot of time to get rolling. And so coming back to this, this is what Whiskey looked like. Just to give you a reminder, they're really not that different. These two things look almost identical. and the little trick that is suggested is just to help load that state very quickly. Okay, so the next thing is packaging. So this is kind of funny. There's a zip file that has one jar. And when you create that and deploy that jar file to the Lambda, it's expecting one jar file. So I did this when I was getting ready for this presentation. And I thought I followed everything I was supposed to do. I was using the examples. And I was pretty proud of myself. I thought, hey, this is working. And so I did the Lambda deploy. And it comes back and it says, zip file is expected to have one jar. You have 63 jars. And I'm like, what the heck? What happened? And so what happened is, of course, all my dependencies just came in as jar files, right? So we need to create an uber jar or a fat jar. And so the way we do that is here. We use the shade plugin, which I'm sure we've all seen before. But there is one other interesting thing is you don't need the embedded Tomcat. So obviously there's a little bit of tweaking that's been going on in the Lambda execution environment because the embedded Tomcat is available to you in the Lambda, so you don't need to set it up. So you can remove that. You actually have to remove that from your zip file. And so there's that. And then the only other thing is, how do we define this handler path? If you remember before when we did the Flask app, it was file.method. So in the case of Java, you need to use a method reference. And so that's just going to be the syntax of the package, double colon, and then the class name. And that, oh yeah, there's that extra bullet. And so here is the Lambda running in AWS. So what happened is here I used that test button. And the interesting thing here is, remember before we did tests and there was like 3 keys and values? On this application, because an API gateway is an input, I actually get a few choices for how am I going to trigger this Lambda. So I picked API gateway, I set an endpoint, and it ran. And you can see that it, down here, printed out the description of a product, so that clearly hit our endpoint. So the question might be, well, why did I do this in AWS? I thought we were using LocalStack. So I'm sad to report that this is what LocalStack gives us. It's kind of a disappointing statement. It says that it needs a method and a context, and it doesn't work. And to exacerbate things further, this is the bug that's been open for over a year, and LocalStack still doesn't support Java. So sadly, I think this just kind of points to the Node Python usage of both LocalStack and serverless. So all the stuff we talked about you can still do, so you can still have DynamoDB and all that. You just can't package your Java Lambda and run it in LocalStack. So that's the only thing, the only gotcha. But otherwise, you can do everything else. So just in kind of wrapping up a little bit, some things to think about, and we've talked about it quite a bit already. Things like the warm-up time of your app, and we looked at how Java can you can help Spring Boot go a little faster. This notion of a one entry per Lambda, and so AWS provides a wrapper for Node. So what we did with Whiskey, you don't have to do that. AWS provides it for you, meaning we had to go to Serverless Framework to get the wrapper. You can get the AWS wrapper for Node. You can get the AWS wrapper for Java. So there's lots of these little wrappers. We talked about this idea of a monolith Lambda, the idea of a Lambda that's running a lot versus a Lambda that's running infrequently, and then, of course, sort of a slightly different deployment model. So real quick, 2 quick stories. When Aurora DB came out, the serverless model, I thought it would be fun to try. So I spun up Aurora DB, then went to my shell and started a MySQL command line and connected to the database, and everything worked. It created some tables, did some queries, and then decided I was going to take off for the day and went out. And I ended up taking like a 3-day weekend. Well, when I came back on Monday, I saw when I went into my AWS environment like a $150 bill. I was like, what happened? Well, it turns out that, wouldn't you know it, that MySQL session, that command line prompt, never timed out. When does that happen? Has that ever happened to anybody? It was there running. I came to my computer never shut down, and that environment stayed up. So I was like, okay, I won't do that again. I created a billing alert. So good to go. Swing forward a few months, and I thought, I'm going to do serverless Fargate, and I'm going to write a Spring Boot app, and I'm going to put that in the Fargate environment with Docker, and I'm going to run a serverless Aurora, because I thought I learned my lesson. Ran everything. It was looking good. I built a code deploy pipeline. I was feeling pretty excited, And again, it's kind of near the end of the week. And on Sunday, I get an email, billing alert, your account's at $100. And I'm like, what the hell did I do now? So it turns out that the JDBC driver does a heartbeat to make sure the database is alive. So the Postgres database never went down, and Fargate never went down because the service was busy. So I think it's just an example of when you move to some new architectures, sometimes our libraries don't keep up with this change of technology. I think there might be a JDBC driver that takes that into account now, but just something to be aware of. So real quick, is it worth it? I think we covered a bunch of things about why you would probably want to use serverless. Some things maybe that you can be aware of when someone comes to you and says, we just got to do Lambdas. At least you can feel like, okay, I have a few things I can talk to you about with Lambdas. And of course, all the different options in the serverless space. Yeah, so we talked about why you might want to use serverless, looked at some frameworks, talked about how that might impact your design. There's one thing I didn't talk about, which is back pressure. So inherently, in serverless, especially Lambdas, there's no back pressure. And by that I mean, if I have a compute instance and I overload it, eventually it's going to run out of CPU. And if I don't have more instances started, I've kind of throttled my system. You don't have that with a Lambda, right? A Lambda will just continue to respond to requests. And so one of the things people will run into is overwhelming your database and consuming all your database connections, or overwhelming your downstream microservices by just hammering them with the requests, and they can't respond and they fall over. And so there are some features, especially in Lambda, where you can set maximum concurrent executions. The default's like, I think, 1,000. You can turn that on or adjust it. But just something to be aware of, that these sort of resources that aren't compute bound can sometimes impact things in a way you might not expect. And that really is kind of this last point, just some things to think about. So thank you. Yeah?